This is Unit 3, Activity 3. So this is just revisiting some of those skills related to graphical characteristics, reading graphs, and kind of clarifying some things because it's difficult the first time you start doing some of this stuff, right? So this first question, let's look at it and let's get us a little pin here. So it says which of the following statements can be made about the graph of h of x um, equals the natural log of cosine of x over the tangent of x when x equals 2. So what we'll be doing is looking for, let's get a better pin here. What we'll be looking for h prime of pi over 2. We just need to determine what h prime is. So if it's if h of x is increasing, so couple things here. If h of x is increasing, I'll know that because whatever h prime of 2 is, it's going to be greater than 0. Now, if it's decreasing, then if this function is decreasing, then the derivative is going to be less than 0. If this derivative equals 0, then I can say that there's a horizontal tangent at this point, that there's a minimum or a maximum here. Minimum or a maximum. But lastly, one of the things I can say is that if no conclusion can be drawn about either of these at pi over 2, because quite frankly, when I evaluate the derivative for pi over 2, I get some value that does not exist. That means there's a break. There might be a break at this point of the graph, which means for the function, or there's a jump, or it doesn't even hit pi over 2 at all. But first, we have to acknowledge that we need the derivative of h of x. So let's look at this function and let's break it into parts here. I have the natural log of, we'll call this cosine of x, right, over the natural log of tan of x. So this is f of x over g of x. So I'm going to use the quotient rule here. I'm using the quotient rule. So h prime of x equals f of x, f prime of x, times g of x minus g prime of x. The great thing about these derivatives is you get lots of practice. It looks so foreign as a concept at first, and then you realize how easy it is. So things I need the derivative of g of x. So g of x equals tangent of x. This is just g prime of x equals the secant squared of x. Now I am going to have to use the chain rule on this f of x here. So f of x equals the natural log of cosine of x. So what I'm going to do is I'm going to substitute this portion, and I'm going to call it u. So natural log of u. And I know with the chain rule, what I'm going to do, what I'm going to get is, if we remember the chain rule, recall the chain rule, and let's ignore this g of x right here, but g of x, it equals f prime of g of x, g prime of x. And I know it gets confusing, so we're going to replace this with our u here and u prime. That's a u prime. All right. So u, if u equals cosine of x, right? then u prime equals negative sine of x. Makes it easier. So if I want to get this derivative here, it's going to be f prime of x equals u, oh sorry, 1 over u, and then u prime. So I'm going to put this stuff together. That's going to be 1 over cosine of x times negative sine x. And I think this is the tangent of x. Yeah, it says tangent of x. And fairly long problem, but we have what we need. We have f of x, which we're going to put here. We have g of x, which we're going to put here and here. And we have g prime of x, which we're going to put here. And lastly, we have f prime of x, which we have right here. So I'm just going to plug these things in. I get equals negative tan x times g of x, which is tan of x, minus secant squared x, natural log of cosine of x, over this derivative over, let's see, g of x squared, which would be tan squared x. So I'm gonna simplify this a little bit, and I'm gonna say h prime of pi over 2, right? This equals negative tan, and it's squared, pi over 2, minus secant, or we're going to say this is natural log of cosine of x over cosine squared of pi over 2 over tan squared of pi over 2. This is I'm gonna eliminate that. That just gives me negative 1. And then over here, I get minus, let's put pi over 2 right here. So the cosine of pi over 2 is 0. So this is going to be natural log of 0 over 0. So because of this portion right here, it does not exist. A lot of work to get does not exist. I did not get a negative value. I did not get a positive value. And I did not get 0. I got a value that says it does not exist. So therefore, the answer here is F. All right? So it says, consider the graph of f of x to the right to determine which of the following statements is true, or true, and or true. So it says when x equals 3, f prime of x equals 0. So only if I have a curve. Remember, corners, these little cusps like this, and breaks are places where derivatives do not exist. Okay, so only way a derivative equals 0, it has to be flat like this, or it has to be a straight line. So here at 3, I have a cusp. This is not true. This is false. That means a derivative does not exist. This is saying a derivative does exist, but this derivative does not exist because it's a cusp. So it says when x equals 2.5, f prime only if f is increasing. So I go to 2.5, we're right in here, so f is increasing, therefore this is true. on the interval from -4 to 5. So this is -4, this is 5. There are 3 values of x which are not differentiable. So what do not differentiable values look like? Corners, cusp, breaks, and holes. So here, hole, break, and a cusp. So this is true. Therefore, the only 2 things that are true here would be 2 and 3. So I hope that clarifies some things for you and helps you understand it a little bit better. So it says f of 7 equals 0. F prime of 7 equals 14. This is true. This is true. Find h prime of 7. So just keep in mind that when we have this kind of derivative, we're trying to find this derivative, we're going to use the quotient rule. So this is your way of practicing so you can memorize this rule. It's just going to be right there in your head, right? So we have all the values we need to have f prime of 7 is 14 times g of x, which is 1, minus f of x, which is 0, times g prime of x, which is 1 over 7, over, let's see, 1 squared, and I get 14 as my answer. Easy stuff. It's just substituting. Let's look at number next. It says the graph to the right shows the data of a function, h of t, which shows the relationship between temperature in degrees and the time in hours. What does the value of h prime of 6 represent? So keywords I'm looking for, it represents a rate, and it represents the degrees over the time, which is in hours. So this derivative represents a slope. That's other keywords. It could represent a tangent. It depends on if it's a horizontal tangent, if it's a minimum or a maximum. So it says represents the temperature after 6 hours is measured. That's no. Represents the rate, so that's a keyword here. It represents the temperature after 6 after, tells me this is a no for a derivative. It represents the rate. Okay. So it says it represents the rate at which the temperature is changing after 6 hours measured in C degrees. Maybe. Represents the rate at which temperature is changing after 6 hours measured in Celsius per hour. And this is the most precise way we might describe this derivative. So the graph of h of x is shown. What is the value of h prime of -6? So we could this is the inverse. So this is preparing you for inverses here. I'm almost tempted to not give you this question right now, but what you can do is find the derivative here. This equals 2 x plus 4 to the 1/2. So the derivative would be 1/2 times 2 times x plus 4 to the negative 1/2. And the derivative of 2 is just 0. So h prime of 6 equals, let's see, that's just going to cancel. I'm going to have 6 plus 4 to the negative 1/2. That's going to be, that's going to be 6 plus 4, 10 to the negative 1/2. Right? So that's going to be 1 over the square root of 10. So I could get that. However, they want me to find the inverse of that at that particular value. And we are not ready for that yet. We are not ready for that yet. Um, yeah. Because remember, the inverse is where you switch the x's and y's, and it won't quite work because we need the function that we need the derivative of inverses. So this is a special one. We can't finish that quite yet. So don't worry about that, guys. Okay, number, and it's rather long too, and I don't want to take all day. Number last, find derivative. So y equals f of x times g of x. Obviously, f of x is x squared. This is a product rule. G of x is e to the x. F prime of x is 2x. G prime of x is e to the x. So if I did this math here, I would have 2x times e to the x plus um, x squared e to the x. I want to pull some things out here so I can divide out, I can factor out two things. I can factor out x to the ex over here and then x to the ex right here, and it's going to come out to the outside. All right, make this smaller, simplify. I have 2 plus x times this quantity times x to the x. Best answer here would be C. So that's all she wrote, guys. Hope I didn't take too long. Hope you heard me clearly. 17 minutes. Have a good day.